Hello, good morning, or afternoon, or evening, or night, whatever it is. Today, let us discuss about ragas. What is a raga? We know that in a harmonium, the reference frequency is very important. And then, there are 12 keys that repeat themselves. For example, if you look at this keyboard, let us say that this is the reference key. Then, there are 12 keys that repeat themselves from here to here. So between this key and this key, there are 12 keys. Okay? Now let us talk about ragas, what this means in terms of these 12 keys. Okay. Now let us look at this board. Let me put it this, maybe this way. Okay. So there are 12 keys. 1, 2, 3, 4, 5. I don't know if you can see this blue pen. Let me try it with the black one. These are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then there is the 13th key. So there are 12 keys on harmonium. So what happens is we do not always use the 12 keys. We pick 7 keys typically out of these 12 keys. Okay? So in any bhajan we usually play 7 keys out of these 12 and we do not pick all the 12. So that is what makes it a raga. Suppose in one case we pick a particular 7, it is raga 1. If you pick different 7, it becomes raga 2, like that. So those 7 keys that you pick give the raga a characteristic. And so the bhajans sound different. How many ways can we pick 7 out of 12? If you know mathematics, you will know that it's 12p7. 12p7 is 12 factorial divided by, I think, 12 minus 7. That is 5 factorial. So which is, it's a big number. If I use the calculator here, so if I look at 12 factorial, it's a big number divided by 5 factorial. So it came to 3991,680. That's a big number. So you can pick 7 keys out of 12 in so many ways. That means there can be so many ragas. And that is very scary, right? If you understand the big picture. So that looks like a big number that scares us. But luckily, that is not really the case. It is more simplified than that. Actually, what you need to do, regardless of which 7 keys you pick those 7 keys and you call them Sari Gama Pada Nisa. Okay? So it becomes Sari Gama Pada Ni. So those 7 keys, the key on the left side is always called Sa. And the next to the right is Ri. And then Ga, Ma, Pa, Da, Ni, Sa. Okay? So we should, instead of 12p7, we should actually do 12c7 because we need to choose 7 out of 12. And the order in which we pick them does not matter. So it becomes simplified problem. It becomes 12 factorial by 5 factorials times 7 factorial. Okay? Now our answer gets divided by 7 factorial. And that became a very small number. I think it is 792 if I am using my calculator correctly. So there are 792 ways you can pick 7 keys out of 12. So you see that the problem has simplified significantly from the number. Now even that 792 number looks scary. Actually it's even simpler than that. why it is simpler, I will explain to you. It is very important to understand these basics. We pick 7 keys, call them sa, re, ga, ma, pa, dha, ni. Correct? And we got a big number 792, right? However, we always pick a reference frequency. So the first key that we pick is reference frequency. It is always sa. So in fact, you are not picking 7 out of 12, but you are picking 6 out of 11, because the first key is always sa. And we know the 13th key is twice the frequency of the first key. And this 8th key is actually 1.5 times the frequency of the first key. Okay? So this 8th key is also reference, generally used as reference, it's always pa. Okay? So those two keys are always fixed. The first key, the 8th key, are sa, pa, and the 13th key is sa, and that is the reference frequency. So if you look here on the keyboard, and let us say this key is sa. Sa, pa, sa. So that becomes the reference, sa, pa, sa. So that is always fixed. So whenever you pick a reference frequency, what you should do is put the first finger on that key, then 8th key is the middle finger, last key is this finger, whatever it is called. And sa, pa, sa. But if you pick this as sa, it becomes sa, pa, sa. So that is your reference. So now, if you look at the board again, the problem has simplified significantly. So instead of picking 7 keys out of 12, you have to pick only 5 keys, because sa and pa are always first key and 8th key. So you have to pick 5 keys out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10, choose 5. You see that the problem is simplified, which is 10 factorial by 5 factorial by 5 factorial. Let's calculate that number. So it is 10 factorial divided by 5 factorial divided by 5 factorial. I think it came down to 252. You see that? The main number of ragas has come down significantly to 252. So its problem is simplified. Now I will tell you some more tricks while it is simplified even further. The rules are, the re key is always picked from one of these 3 keys, and ga is picked from one of these 3, is ga. Ma is picked from one of these 2. Da is picked from one of these 3. Ni is picked from one of these 3. Okay? So how many ways can you really do? Actually you pick one out of these 2 re ga are picked from these 4 keys basically. If you look at it, so it is 4 choose 2, which is 4 factorial by 2 factorial times 2 factorial, which is 6. I think. And ma can be chosen from these 2 in 2 ways. Correct? For ma. For da and ni, you can again same thing as 4 choose 2, which we know that is 6. So total number of ways you can pick ragas is 6 times 2 times 6, which is, let's use a calculator. Actually we don't need to use a calculator. 6 times 2 is 12. 12 times 6 is 72. So that is the very simplified number. So there are 72 main Melakarta ragas in Carnatic music. Okay? So all you need to do is pick the first key as sa, 8th key as pa, 6th or 7th key as ma, 2, 3, 4, 5 keys as re and ga, 9, 10, 11, 12 as da and ni. So there are 72 ways you can pick these ragas. Okay? So this is lesson 1A, and I will do lesson 1B after this. I don't want to run out of time so that YouTube does not let me load it. Sai Ram.